Good morning, my dears. My name is Dr. Pathan Hussain Basha, working as a assistant professor in the Department of CSE. Now, today I delivered on automata theory and compile design concepts. So, in this, today we are learning about the understanding the conversion of the finite state machine. So, it tells the what are the finite machines are there. In that, how to convert the one machine to the another machine. Not only that one, if you are learning that one, these are the outcomes will become here. That is utilization of the conversion of finite state machine. If you are converting the one state to the another state machine, then it will convert you what are the utilizations are there in that particularly we have to learn. The next, now today we have concepts covered by the NFA to DFA conversion. NFA to DFA conversion. So before going to discussion of the conversion, here I have to explain a little bit of the what is NFA and what is DFA. So here I am taking one example for NFA, that is so if you are observing the difference between the NFA and DFA, here P is the state that is having the initial state. P is the initial state. The state is having that zero transaction, and again zero transaction with the P1, and again P1 is P having that one transaction with the P1. So here, if you are observing here in DFA, Q naught is having that only the zero transaction is one, and one transaction with the Q1. So that is the difference between the NFA to DFA. So let us take another example for conversion of NFA to DFA. So here I am taking NFA diagram like this. So here the Q is having that Q naught and Q1. So these are the states we are taking in NFA, that is Q naught and Q1. So here Q naught is taking as a starting state or else initial state. So here the 0 is having that self transaction for Q naught, and at the same time Q naught is having that 0 transaction input, it will reach us the Q1. So again Q naught is having that one transaction with Q naught, it will reach us to the Q naught. So in this way the diagram having representation. So we are taking the alphabets 0, comma 1, and here delta, it the formula of delta is q into sigma, it reaches the q next state. It means that q naught having the initial state, here the above diagram having that q naught is the initial state, f it represents the final state. The final state of the given diagram is q1. Like this only we have to write down the 5 tuples of NFA, 5 tuples of NFA. Then next we have to do one thing, that is transition table. So on the above diagram we have to draw the transition table for that one. So here 0, comma 1 is there. So here I am doing the one thing, that is Q naught is having that delta, Q naught is having that 0 transaction. What is the next state? So here the Q naught is having that 0 transaction with self transition Q naught, and again Q naught is having that zero transaction, it reaches to the Q1. It means that, so here two states are there. Q naught is having that along with the zero transaction, it reaches the next state, Q naught, Q1. Okay. So here the next Q naught is having that again one transaction, it reaches to the Q naught along with the one transaction, it reaches to the Q1. So Q1. So here Q naught is having that zero transaction with two states, that is Q naught and Q1. It is created a new state, but unfortunately here we have the only Q naught and Q1. But if the zero transaction of the Q naught, it reaches the another state, that is Q naught and Q1. So based on this one, we have to simplify this one, Q naught, Q1. Again we have to simplify this one, delta Q naught comma Q1 along with the zero transaction. So here the simplification of this equation like this, delta Q naught 0 union of delta Q1 0. So here if you are observing, delta Q naught is also having the above. So delta Q naught is having that the equation like this, Q naught comma Q1, again union of Q naught Q1 with zero transaction, Q naught does not have the zero transaction with this. So that's why here we have to write down pi. There is no state element is there. That's why it reaches the Q naught Q1. Here I have to write down the state of Q naught Q1 here. So then next simplification of next simplifications of delta Q naught comma Q1 along with the one transaction. So here the simplification like this, delta Q naught 1 union of delta Q1 1. Next here the Q naught 1 is having that Q naught 1 transaction with reaches the Q1 union of Q1 1. Q1 along with the transactions, two transactions are there, that is Q naught comma Q1. So the union of the Q1 and Q naught Q1 write like this simply, Q naught comma Q1. So it means that the Q naught and Q1 along with the input transaction 1, we reach the these states, Q naught comma Q1. Okay. So here already we have to simplify the Q naught 1, Q naught 1, Q naught 1. Already we have to simplify all those things. So there is only one thing, that is Q naught. Q naught with zero transaction, there is no state is there. That's why we have to write down pi. And again Q naught is having that again Q naught comma Q1 is there. So Q1 is having the self transaction, and as well as the Q naught is having the one transaction with the Q naught. So that's why you have to write down Q naught and Q1. So again here I have to write down Q pi. It means that pi is having the zero self transaction. This is the way to representation of the transition table. So based on this transition table, we have to write down the transition diagram for given table in the DFA manner. So here I have to take the first Q naught is the starting state. Then again Q naught with the zero transaction, it reaches the Q naught comma Q1 state, zero transaction. Again Q naught is having that zero transaction, and one transaction it reaches the 1. Again Q naught and Q1 is having reaches to the Q1 and Q2. The next Q naught into Q1. So self transitions 0 comma 1. So Q1 is having that 0 pi. So in this way we have the representation of the DFA in simple manner. DFA, deterministic finite automata. So here we have to take in the Q naught 0 and 0 1 transaction, and Q naught is having the 1 1 transaction. Here if you are observing, the Q naught is having the 0 transaction to the Q naught and Q1. So here the Q1 and Q naught is having the 0 comma 1 self transaction. In this way we have the representation of the conversion of the NFA to the DFA. So next we have to focus on the next one, minimization of DFA or else finite state machines. So here we have to minimization of the DFA machine. So for example, here I am taking the one DFA machine like this. So this is a DFA machine. First of all, we have to see this diagram is follows the DFA rule or not. So here the Q naught is having the initial state, that one having the 0 transaction with the Q1, and again Q naught is having the 1 transaction with the Q3. So this one is follows the DFA rule, and as well as here also Q naught is having that transaction to 0 transaction with the Q2, and along with the Q1 is 1 transaction with the Q4. So here Q2 follows the 0 transaction with Q1, and Q2 follows the 0 transaction with the Q4. So Q3 also follows the transaction with the 0 transaction with the Q2, and Q3 follows the 1 transaction with the Q1. So in this way, so that the given diagram is follows the DFA rule. So based on this one, we have to draw the table, transition table. So here Q naught follows the 0 transaction with the Q1, Q3 here, Q1 is having that Q2, Q4. So Q2 is having that Q1, Q4, Q3 follows the Q2, Q4. So this one is having the self transaction. So in this way. Next, here the totally 5 states are there. We have to reduce the states, but it follows the DFA rule. So that is the main concept of minimization of DFA. So that's why here I am taking that equivalence. So equivalence means here there is a one rule is there for equivalence. How many finite states are there? Those I have to write one side, and those who are having that non-finite state, they are taking as another side. So here I am taking that the above diagram having that Q naught and Q1, Q2 and Q3. These are all non-finite states. Non-final states. So here there is only one state is there, that is final state Q4. So here the given diagram having that Q4 is the final state, and remaining 4 is having that non-final states. So again we have to simplify this one equivalence. In the 0 equivalence we have to take in that non-final statements and final statements. Here there is only one statement is there, this one is not simplified. So but here the state is having that 4 internal states are there. Those can be simplified. So for simplify purpose here I am writing that comparison is there. So compare with the 0 starting element with the q1. So here the first starting element is there, first starting state is there. This can be compared with the remaining states. So q naught with 0 transaction, it reaches the q1 state. So q naught q1 with 0 state, it reaches the q2 state. So here q position, it reaches the q3. q1 one transaction, it reaches the q4. If you are observing that the comparison of q naught and q1, q naught with 0 transaction, it reaches the q1 state. q1 0 transaction, it reaches the q2 state. q naught with 1 transaction, it reaches the q3 state. q1 with 1 transaction, it reaches the q4 state. It means that it reaches the different states. So here there is no comparison is there, q naught q1, q1 q2 q3 q4. So here there is no comparison is there. So that's why here I am writing that q naught is a separate state, and as well as q1 is a separate. So here as it is the q4 is there, final state. Again we have to compare q naught with q2. So again q naught with 0 transaction, q2 with 0 transaction, q naught with 1 transaction, q2 with 1 transaction. So q naught with 0 transaction, it reaches the q1 again. q2 0 transaction, it reaches the q1. q2 sorry q naught with 1 transaction, it reaches the q3. q2 with 1 transaction, it reaches the q4. If you are observing that q naught 0 transaction 1 and q2 0 transaction with 1 q1, q naught with 1 transaction q3, q2 1 transaction with q4, but these are all same, but here the one transaction q3 q4 is not same. So here again q2 have to write down another separately. So again we have to compare again q naught with q3. So here q naught with 0 transaction q1, q3 with 1 transaction, sorry 0 transaction, it reaches the q2. q naught with 0 transaction, it reaches the q3. q3 with 1 transaction, it reaches the q4. So here it reaches the different states. There is no common at all. So comparison, there is no equal and there is no common at all. So that's why you have to write down again q3 is separately. Okay. In the first equivalence from 0 to 1, we have to having this much of information. So 0 equivalence is having that non-final states is having that q0, q1, q2, q3 and q4 is the final state. So in the first equivalence completion, it reaches the q0 is having that separate state and q4 is having the separate state. So remaining q1, q2, q3 is there. We have to simplify these one. In the second equivalence, we have to write q0 is separately and q4 is having separately. So here the comparison between the q1 with q2. So here q1 0 transaction, q2 the 1 0 transaction, q1 with Q2 with one transaction. So here observing that Q1 with zero transaction, it reaches the Q2 state. Q2 zero transaction, it reaches the Q1 state. So Q1 one transaction with the Q4 state, Q2 with one transaction, Q4 state. So again here, if you are observing, these two are having that same, but these are all different states are there. There is no comparison between this one. So that's why here I have to write down Q1 and Q2. Again compare between the, again compare Q1 with Q3. Q1 with zero transaction, Q1 with zero transaction, Q3 with zero transaction, Q1 with zero transaction, Q3 with one transaction. So Q0 with zero transaction, it reaches the Q2 state. Q3 zero transaction, it reaches the Q2 state. Q1 zero transaction, it reaches the Q4. So Q3 having that. So if you are observing Q0 to 0, Q2, Q3 zero transaction with the Q2. So these two are having that same, and again these two are having that same. It means that both are having the equivalence. That's why you have to write down here Q3. If you are observing the equivalence one by after one, zero equivalence having that two states, one equivalence having that three states, the second equivalence having that four states. So here again the combination of Q2, Q1 and Q3 is there. Again this one is having that simplify. So Q0 to zero transaction we reaches the Q2, Q3 zero transaction we reaches the Q2, Q1 one transaction we reaches Q4, Q3 one transaction we reaches the Q4. So here also Q4 and Q2 is having that same in equivalence. That's why we have to write down Q1 comma Q3 is having that one state. So an equivalence balance minimization of the DFA is reaches, the table is like this and equivalence is like this. From zero equivalence we have the two states, one equivalence three states, second equivalence four states are there, in third equivalence having the four states. Based on that one, based on the equivalence and along with this table we have to draw the table transition diagram like this. Q naught having that starting state, the next we have to take in Q naught and Q3 is having that separate state. Q naught to zero transaction, it reaches the Q1 state, 0. Q naught with one transaction, it reaches the Q3, 1. Then next Q1 with zero transaction, it reaches the Q2. So here I am writing the Q2. So Q1 to zero transaction, it reaches this one. Q1 along with one transaction, it reaches the Q4. Q2 is having that zero transaction with Q1. Q2 with one transaction with Q4. Q3 is having that zero transaction with Q2. Already it is there. Q3 is one transaction with Q4. This one is already there. Q4 is having that self transaction 0 comma 1. So after minimization of the DFA like this, in the above diagram having that 5 states along with the 0 and 1 input, and as well as it follows the DFA rule. As it is here I am reducing the or else minimizing the given diagram like this. Q naught is having that 0 state, and along with the 0 and 1 transition to the Q1 and Q3. So Q1 and Q3 is also having that 0 and 1 transaction to the Q2 and Q4. So here the Q2 is having the transaction with the 0 to Q1, Q3 state, Q2 with 1 transaction with the Q4. So here Q4 is having the self transaction 0 comma 1. Like this, we have to minimize the given DFA to given DFA. So here the above diagram having the 5 states, and here the given solution of the minimization of DFA is having that 4 state. So like this, we have to minimize the DFA to NFA. Now we are discussing about the another concept, that is equivalence of equivalence of equivalence between the equivalence between two finite state machines. So another concept, equivalence between two finite state machines. So here I am taking the two finite state machines like DFA diagram. So here I am taking the two different DFA mission diagrams. So here the Q naught is having that starting state, and along with the zero transaction to the self transition, Q naught is having the one transition to the Q1. So here the Q1 is having the self transaction with the 0, and Q1 is having the one transaction with the Q naught. So based on this one, here I am writing the transition table for this given diagram. Q naught comma Q1, Q naught, Q1, Q1, Q naught. So here again also having that another machine, that is P naught is having that starting state, and zero transaction with the self transaction P naught, and one transaction with the P1. So that is the final state. So here the P1 is having that self transaction with 0, and the P1 with one transaction it reaches the P2. P2 is also having the 0 with the self transition, and P2 one transaction with the reaches the P1. So based on this one, here I am writing the transition table for the given diagram. So P naught 1 reaches the P1, so it reaches the P2, it reaches the P1. So like this. So here equivalence between the two finite state machines. Here I am taking the two machines. After that, the simplification of the transition table like this. So after that, I want to equivalence between these two diagrams. So for the purpose of need, I need that here I am taking zero equivalence. Zero equivalence. So here only one state is there, and having that another final state. There is only one non-final state and one is a final state. For this diagram, no need to be the equivalence. So here we have to find out that non-final states are P0 and P2 having that non-final states, and another one P1 is having that final state. So here I have to find out that non-final states are 2 and 1 is the final state in the zero equivalence. For simplification of the next P0 to P2, so here I am doing that one equivalence, one equivalence. So here I want to compare between the P0 with P2. So P0 with P2. So for that purpose here I am writing P0 0 with P2 with 0, P1 with 1, P2 with 1. So P0 to 0 transaction it reaches the P0 state, P0 with 1 transaction it reaches the P1 state. So P0 with 1 transaction it reaches the P1, and P2 having that 1 transaction it reaches the P1. So here this one is having that equivalence. So here both of them there is any one of the state is equal value, then another one is taking as a equal value. So here in the above cases minimization of the final state machine, two cases are having that equal, but here in the minimization equivalence between the two states, any out of any one is equal, it will taking as a equivalence of the equal. The next P1, P0 and P2 is having that same state, and P1 is having that final state. So based on this equivalence one, we have to draw the table, that is P0 comma P2 is having that one state, that one is a starting state, and next P1 is another state, that is the final state. Okay, from P0 to P1 it reaches P0 to self transition 0, and P2 is having that self transition 0, P1 to 1 to P1, so it reaches the P1, and P2 also one transaction which reaches the 1. Then next P1 is having that self transaction 0, and it reaches the P1. So this is equal because of here having the two states Q0 and Q1, here also two states P0, P2 and P1, two states are there. Here the follows DFA rule, here also follows the DFA rule. So based on this one, along with the tables and along with the diagrams, we have to represent the equivalence between the two states are equal. So this is the information about the NFA to DFA conversion, and as well as the minimization of the finite state machines and the equivalence between the two states. So these are the information we have to provide in this class. Thank you.